Imagine for a moment a universe unlike the one we inhabit today, not the vast star-strewn tapestry we gaze upon, but something profoundly different. Picture an impenetrable, ethereal veil draped across all of existence. This isn't science fiction, it was the reality of our cosmos, roughly 300,000 years after its fiery inception with the Big Bang. At this incredibly young age, the universe was filled with an opaque, uniform fog. This wasn't a wispy mist, but a dense, suffocating cloud of neutral hydrogen atoms. These atoms, lacking the energy to be ionized, acted like a thick blanket, absorbing any light that tried to pass through. It meant that for hundreds of millions of years, the young universe was, to put it simply, invisible. There were no stars shining, no galaxies glowing, just a featureless cosmic murk, a period often referred to as the cosmic dark ages. No light could travel freely, and thus no information could reach us from that time. So, how did this profound darkness lift? How did the universe transition from this featureless, opaque state to the dazzling, transparent expanse we see today? The answer lies in the dramatic reawakening of light itself, sparked by the very first cosmic bodies. As the universe continued to cool and expand, gravity began its tireless work, pulling together clumps of this neutral hydrogen. Over immense spans of time, these clumps grew denser and hotter until, at their very hearts, the immense pressures ignited the first nuclear furnaces. These were the birthplaces of the first stars, and soon after, the nascent structures that would grow into the first galaxies. When these colossal new sources of light and energy burst forth, they didn't just illuminate their immediate surroundings. Their intense ultraviolet radiation streamed outwards, acting like a cosmic electric current. This energy began to ionize, or electrify, the surrounding neutral hydrogen atoms, stripping away their electrons. As hydrogen became ionized, it also became transparent to light. One by one, then by the billions, these pioneering stars and galaxies gradually began to carve out bubbles of transparency in the opaque fog, much like dawn breaking through a dense morning mist. This transformative period, when the universe finally became transparent, is known as the epoch of reionization. Now, you might wonder, how do we possibly know any of this? How can scientists peer into a time that was, by definition, invisible? The answer is one of the most astonishing triumphs of modern astronomy. We can, in essence, look back in time. Because light takes so long to travel across the vastness of space, the light we receive from distant galaxies left them billions of years ago. By observing objects that are incredibly far away, we are literally seeing them as they were in the distant past. To truly glimpse the early moments of the epoch of reionization, astronomers employ ingenious techniques. One particularly powerful method is known as gravitational lensing. Imagine a colossal magnifying glass in space. When the light from a very distant faint galaxy passes near a massive galaxy cluster in the foreground, the immense gravity of that cluster bends and amplifies the light, acting like a natural telescope. This improved gravitational lensing technique has allowed scientists to peer more than 13 billion years into the deep past, offering a window into the cosmos when it was a mere 500 million to 1 billion years old. The primary target for these intrepid cosmic explorers was to find the very first stars ever born, the elusive population 3 stars. These theoretical first-generation stars, composed only of hydrogen and helium, were thought to be massive and short-lived, the progenitors of all the heavier elements we see today. Finding them directly would have been a monumental discovery. But, as so often happens in the pursuit of knowledge, the universe had a surprise in store. While the researchers didn't directly find their primary target, the population 3 stars, what they did find was perhaps even more profound, completely reshaping our understanding of the cosmic dawn. They discovered a surprising abundance of galaxies already brewing, far more than anyone had anticipated for such an early time. These weren't just any galaxies, they were incredibly faint, up to 100 times fainter than any previously detected, and possessed much lower masses than anything the venerable Hubble Space Telescope had managed to spy so far. This startling discovery carries immense implications. The very existence of so many small, faint galaxies at such an early stage suggests something remarkable: that the first stars, the building blocks of these galaxies, must have formed even earlier than previously thought. It implies that the universe wasn't a slow burn, gradually illuminating itself. Instead, it seems the process of reionization, the lifting of the cosmic fog, was incredibly efficient and surprisingly rapid. Think of it, a mere 500 million years after the Big Bang, a blink of an eye in cosmic terms, the universe was not the barren, empty void once envisioned. Instead, an unexpectedly rich collection of galaxies was already hard at work, their collective brilliance acting as countless little lighthouses, ionizing the opaque intergalactic murkiness of neutral hydrogen. These early galaxies were the pioneers, the first architects of light, transforming the universe from a veiled enigma into a place where light could finally travel freely, illuminating the path for all the galaxies, stars, and planets that would follow. This revelation reminds us how dynamic and vibrant the early universe truly was. It wasn't a slow, quiet awakening, but a powerful, energetic burst of creation that quickly filled the cosmos with the light that defines it today. Our journey to understand the universe is an ongoing story, constantly being refined and made richer by such extraordinary discoveries. What do you find most fascinating about the universe's early moments, and how this cosmic fog lifted? Share your thoughts in the comments below. And if you found this journey into cosmic history enlightening, please consider following for more explorations of our universe.